Hello, fellow YouTubians. My name is Terry Andrews Jr., also known as the J5 Guru. I hope this video turns out okay. I will not be stopping it or editing it. So if you hear the occasional horn beep or traffic pass by or anything else, deal with it. I had more important things to do. So today is October 22nd. 2021. It looks like 11:18 or well, nope, 11:19 in the morning, and it's 57 degrees out. The warm weather is finally over here in the Northeast. It's going to get cold. Anyhow, so what you're looking at here is the culmination of many months in design iterations for the Johnny 5 battery box modules that are located in each track drive. As of right now, no one else has these designs, okay? Myself and Ramon worked on these, went through many different iterations, and I'm going to ask this of the community. If you can donate to, Input Inc., to the project, please do, and do it until it hurts, okay? The 8 cells that you see here were purchased some time ago, at least a year ago, maybe a little bit longer. They were over $1,000. Now the price on these has dropped dramatically. These are 105 amp hour, 3.2 volt lithium iron phosphate battery cells. Okay, and that's what we're using in the robot. These are an inherently stable chemistry. If something goes wrong, the likelihood that these are not going to explode, they're not going to catch fire. They are a stable chemistry. They are lithium based, but they are not lithium like the 186, the small batteries you see that are always blowing up, on the internet, like here, the ones in my vape. Yeah, these cells, yeah, when they something goes wrong, they tend to catch fire and explode, and yeah, these ones don't. They simply vent. You don't want to breathe in what they vent, but yeah. So anyhow, so this system utilizes an Overkill solar. Oh yeah, again, please donate. Every penny that we spend doing the research and the R&D saves you, the builder, money. So it's an investment, okay? It's an investment in making sure that when we say, yes, do it this way and it will work, you don't have to do the trial and error and waste the money. And trust me, we have blown through so much money because of the iterations that did not work that we thought would work. So anyhow, please donate. Go to input-inc, that's INC, all one, so input-inc.com. Go to our webpage. There's a donate button down there, PayPal somewhere. Please donate, because yeah, it helps. Money makes the project move forward, quite honestly. So we're using the Overkill Solar BMSs, okay? Will Prowse on YouTube reviewed these things. He raved about them. So that is what we're recommending. These are 4S BMSs. And here's one here. There we go. Still got the, yeah, they test these before they send them out. So you're guaranteed, for the most part, something that's not going to be a dead-on arrival, a DOA. Okay. Now, you can go to the manufacturer and you can buy this BMS. Of course, like everything else, it's made in China. But we've found that this part number, when ordered directly from the manufacturer, you do not get this BMS. You get another BMS with the temperature probe exits out the bottom. And also we've found with the other version, which is significantly less money, this BMS has 30 MOSFETs on it, okay? The BMS sent from the manufacturer only has 24. Also, there are large diodes, where are they at? There are large diodes on here, there we go. These large diodes that line the back here, okay? I'm not sure what they're for. This one has 8. The one from the manufacturer with the same part number has 4. So my understanding from what Will Prowse says, and I haven't been able to get any documentation or a reply back except for a boilerplate. I asked Solar Overkill what's the difference between their BMS and the one from the manufacturer, and I really didn't. I got kind of a boilerplate answer. Anyhow, so apparently these are supposed to be medical grade. Again, I can't find anything that says, any documentation. But obviously there's more in here. And the metal bus bars, the pieces, yeah, they're longer. There are differences. So we are recommending the Solar Overkill unit only because we know that this one has been tested by Will Prowse. He raves about it. They have a, basically, something goes wrong with this in the first year, send it back. They replace it free of charge, no problem. You buy it from China, well, yeah, you get no such, no such warranty or guarantee. And it's not pre-tested when it leaves. Here, they give you all of the test results printed out here. Ensuring that when you receive this, you're going to receive a working unit. This has a Bluetooth connectivity, okay, through an app on either an Android or an iOS device. Order it with the long leads, okay? I think they're 22 or 24. It's an option. Order it with these, okay? You're going to need these long, all right? You could do it yourself, but hey, it's not that much more money. And they're nice 8-gauge silicone wires, very flexible. They're just beautiful. Yep. The other thing you will need to order, again, not much money. I think it's like under $10. Order the USB module for it so you can connect it to a PC. There are a few more parameters that are accessible through the PC utility that are not accessible through the app, as I understand it. So, in my other video, which actually is private right now, I'll have to make it public, I showed how I made these field expedient insulator caps. They're just a wing nut, an electrical wing nut with a hex head, a 1/4-20 hex head inserted in here. These batteries come standard with like an M3 or an M5 or M4, I don't know what it is, little weedy little bolt that goes in there, and it strips these things right out proper. Okay, so I helicoiled these in a previous video, and I also inserted 3/4 inch long grub screws, and I Loctited them in with blue Loctite. Okay, yes, I know. Don't leave comments saying you shouldn't have done that. I know. There's arguments both ways, and I'm going with the argument that as long as the lug is mated directly to the terminal surface, you're really not going to have a problem. And the fact of the matter is, these studs need to be able to hold up to vibration and abuse, and we can't have them coming loose. So, all right. So I'm working with large batteries here. There is always the potential for short circuit even with these things on here, so I take off any metal or rings that I currently have on my hands or about my person and put them out of the way. So we're safe to work on these things. So I haven't done this before, but I've kind of gone through the thought processes in my head and kind of pre-prepared. I don't have Kapton tape, so I'm going to be using electrical tape, which in my application is going to be fine because I figure I'm going to be tearing these things apart a couple times anyhow. So This is the bottom of the BMS case, okay, or the battery case. Let me show you on this one here. These have some inserts in here. I don't know if you can see. Yep. Inserts, threaded inserts. They're a special kind. When we release the files, you'll see it. Anyhow, so what I need to do is I need to get these batteries, and I need to get them so they fit, so that they're held together, okay? So when I go to put these in here, and these, all this stuff is a tight fit, okay? It's not bad this way, but the sideways, there's not a lot of play because these cells vary as far as whether or not they're swollen or not. But so here's the best way I found to do it, because if I try to insert all three of these down in there, it's too tight. So what I'm doing, check the bottom here, going in like this, and now this one's going in. I align it up, and you can see where it's already tight. It's kind of wanting to force the tops apart. There we go. And I'm going to work that down in there till that bottoms out. There we go. All right. So if I go right now and I try to fit the battery top on, okay, this will not go down on. These batteries are splayed apart, okay? So what I need to do is technically not compress them. It is compressing them, but not to be confused with, compressed LiFePO4 cells, okay? I just need to draw these things. You can see how they're moving. Okay, I need to draw these things in so when I go to install the top, it's a lot closer to being aligned than what it currently is. So here's what I've come up with. Field expedient method, just some 2x4s with screws on the end. And what I'm doing here is I'll just latch onto here, grab onto here. Got to use my chest here. Need another hand. Oh, I see the mailman. Hello, Mr. Mailman. Yay. More bills. Again, please donate. Okay, so there we go. There's that. Now, what I have here is I have some, I guess, furring strips I had laying around. Now what I'm going to do is I'm going to take a C-clamp on one side. Here we go. I've never done this before. I just sort of mocked it up. So there we go. I got one C-clamp there. Let's see. The idea is I want to get my spacing. So, okay, this can go like that. Here we go. Press this down like that. Now I'm going to draw all these together. Okay, and I can already see they're going closer to close. Do not over tighten these things, and do not underestimate the amount of clamping force that you're applying every time you turn these things, okay? You do not want to crush the cells or dent them, okay? Now I'm going to take my top, I'm going to put it on here and see if I am close to my target. Let's see. Okay, that is tight. There's no doubt about that. Oh, wait a minute. Do I have it wrong? Yeah, okay, I'm going to turn a little bit more. A little bit more. That's about as much as I feel safe doing. And there we go. A nice snug fit. You'll also notice my insulator solution allows me to keep these insulated but still put the top on. So the whole purpose of doing it this way is so that I can put a wrap of tape, preferably Kapton tape, but again, I don't have any here. Please donate. All right, so there we go. So I'm going to use electrical tape. And this is solely to hold these batteries, there we go, in some sort of kind of neutral sort of position. The reason I put these blocks down here like this is so I can kind of do a nice even tape here. So I'm going to go around, I'm stretching this, going around, stretching it, and I'm just going to go around like this a couple times. There we go. Come on. There we go. All right. And I'm going to go one more time here. Again, I'm not going to make this super pretty because I'm more than likely going to be tearing this apart. So, getting near the end here, give one final, there we go. All right, now I'm going to start easing up on this so it doesn't pull loose due to being stretched too tight. And I think that's pretty good right there. All right, and where is the razor? Here's the razor. I'm going to put a dog ear on here so I can easily take this back off. Just around there like that. All right. So, please excuse the crudity of this video. So, yeah. That's what we're looking at there. Okay. So, am I back in frame correctly? I guess so. Alright, now of course this tape will stretch a little, so, but there again, this is to get it ballpark, so it's not so far out that you're really struggling to get it back together. Take that off. Take that off. Okay. Now I see if this top fits on here reasonably easy. Let me see here. There's that. There's that. There's that. Yep. That achieved what I wanted to do. Okay, so I want to do the bottom of it now. Again, keep them tight. So how am I going to do that? Well, in theory, if my thought process has been correct, now is the time you want to be careful, boys and girls. Because we are now dealing with hundreds, if not thousands of amps of surge current. So my thinking is if I put this top back on, like so, let me see here. There we go. Okay. And I flip this over like this. You can see the terminals do not stick out of the top. They get a cover. I will show that in a while. Okay, now I'm going to try. Oh yeah, that's tight. That's all right. You don't want these batteries flopping around now, do you? There we go. Now, of course, since the top is compressed, the bottom wants to, yep. So, in theory, rinse and repeat. Put this over here, this over here. Again, needs 3 hands, don't have 3 hands. And there. Okay. There's that. Put this down here, this down here. Now, some pressure. Again, don't get carried away with the pressure, for God's sake. Okay, let me see if that helped. Might have to open up the tolerance on this a little bit. Let me see. And might have to do a little CAD tolerance there. Oh well. See, again, we do these things so you don't have to. Yeah, this is like, I think this is like a, is this, no, this one, yeah, it's over a day to print it. I think it's like a 26-hour print. Let me see. Okay. All right, so you got to work for it, but it will go on. So, yeah. Again, it's just to get these batteries ballpark, okay? Because obviously if they're under no pressure at all, you can kind of see even under pressure. It's kind of a pain in the butt to, I'm going to get that just a little bit more. There we go. All right. Rinse and repeat. These are tape here. There we go. All right, I'm trying to do this reasonably rapidly, but, well, I want to do it right also. Again, I think Kapton tape would be the preferred way to do this. But I don't have any on hand. Again, please donate. You're helping yourself in the long run. You help us, it helps you. You don't have to second guess. You don't have to buy 3 different kinds of motor speed controllers to find out the one that is reliable and works the best. You don't have to buy 2 different kinds of battery cells to find out which one works the best or fits. Yeah, that's what Input Inc. does for you. Not to mention we provide the design files for free. So, yeah, share the love a little bit. Okay, so I'm easing up on this, on tension, so it doesn't come loose automatically. I probably went with a few more wraps than I should have on that one. And where's the razor? There you go. Okay. And a little dog ear on here so I can readily take that off when it's required. All right, so in theory, this will hold this battery, these 3 cells, reasonably close. Here we go. One there, one here. And now if I try to put the bottom on, again, it's going to be tight. I already know that, so, but this is to get it ballpark. Yeah, I think we got to open those tolerances up. Ramon? Well, actually, that's not too bad. I mean, that's doable. It's not like you have to do this every day or something. Okay. Yeah. I can deal with that. Okay, so for the rest of the magic that you're probably wondering how this all goes together and works. So I'll take this top off here. And for safety, I am going to put the insulator caps back on because I'm going to be getting metallic objects near. Again, I'm sure you can probably buy like a 1/4 binding post or something, insulated binding post that would do this. This is just stuff I had laying around, and it works. It gets the job done. So there we go, and then this is one half of the 24-volt power supply. It's an 8S configuration in total, but we're running each pack as a 4S BMS controlled pack that gets hooked up in a 24-volt configuration. Okay. So BMS is in here. We've designed the case so that it has a relief in here for the temperature probe. Okay. This BMS is inserted in here. There is allowed to be airflow around the BMS. It doesn't need it, but yeah. So it is set up in there. What we have in the bottom, you'll probably notice this squirrely little cutout. Okay, so first of all, don't run your Johnny 5 in the rain. Do not go swamp buggy racing with it. Do not run it through mud puddles don't expose it to the elements, okay? Bad things can happen, okay? Entry of moisture into the system. Hey, watch Short Circuit 1. Yeah. Newton Crosby explains all the possible things that could make the robot malfunction. Anyhow, what we've done here is we said, okay, this will be outside at some point. And despite your local weatherman's prediction that there's going to be no rain today, inevitably you may have this at an outside event and you may get some rain or a passing shower, or the ground may be wet. You know, you have to run it through a mud puddle to get into a venue or out of it. Regardless, let's just say at some point you're in a situation where it's going to be, the track drive's going to be exposed to the elements: snow, water, ice, whatever. The tracks will pick this stuff up, will drop it down onto your expensive battery pack, and of course, bad things will happen. So what we've done is we've made this to mitigate or lessen the likelihood that water will get into the system. And if water does get into the system, there's a small angled basin down here with a weep hole at the bottom, which will allow any water that does get in here to escape. Okay, so it's not a puddle of water sitting in here. Okay, so what happens is, and I'm going to do it, well, I guess I can do it that way. So the BMS we've done, our one temperature probe gets put on a pack, okay, probably right in here. You place it somewhere, Kapton taped on. I'm not sure which wires go where, or actually, yes I am. Okay, so this is the negative. This would be out of the track drive. So here's the basic premise. This BMS enclosure keys in down at the bottom like this. Okay, boom. That keys in. So there's your BMS. So any water that hits this runs down along the side into the basin and out the weep hole. But there's still, wires could go through, air can circulate through there, so it's not a completely enclosed box, okay? Then this wire, this set of wires here, comes up over and captures this cell, because right now this is your positive out. Your negative goes through a bus bar to here, okay? Then bus bar from here to here, okay? Then a bus bar from, let me see, here to here, okay? and then this out to the BMS, which is basically a big switch. Okay, and that's how this goes. And then this one goes to your negative of your power pole connector, and I'll show you that. So this is the top of the BMS case, okay, or the battery case. So what we have here, please excuse the crudity of this video. We have a cover here to cover all the terminal openings. This way you can remove the cover, you can get in there with a socket, you can check the tightness of the lugs, okay? You can do voltage measurements on a cell per cell level, right, you know, just by removing that. Same thing with up here, but it's a little bit more complicated because you have to, let me see here. Oh yeah, okay. This has a bottom piece. This is where the Anderson power pole connector goes. I think this is an SB120. It's used in industry. Don't get cheap knockoffs. Yes, it's expensive. Deal with it. You're building a robot, not a toy. Don't cheap out on the electrical systems, okay? So, any water that hits this runs down along the edges, down along the sides, boom, doesn't get into any of the expensive or, you know, parts or affect any of the angry pixies or get on things and cause rusting issues, any of the lugs, anything like that, okay? So basically this covering comes off, which exposes the Anderson power pole connector underneath. The wires loop up around, down into the top of the battery case, okay? So just imagine it like that. And there you go. That's your J5 battery pack. It has threaded rod that attaches the top and bottom together. So I'll give you a little, let me see. So this should, yeah. Now this I've never tried to do, and this is probably going to be fun. Trying to get all of these things to mate in here at once. But, oh, there we go. Okay, there we go. So far, so good. I got to get the BMS. There we go. Yep, there we go. Okay, that actually wasn't hard at all. Okay, there's still a little, oh, my BMS, there it is. Okay. The BMS case is captured by the cutouts in the bottom, keys in at the bottom and at the top, okay? There's a gap between the top of the battery to run your flexible bus bars and wires through there, and your BMS leads. Of course, these go up through the top. You know, they'll kind of go up through like this, okay? And then this one goes up through here. Let me see here. Yep, goes up through here like that and into the Anderson power pole connector, okay? This is why you want these long leads, okay? Yeah, just pay the extra couple bucks. It's worth it. They do a fantastic job. Overkill Solar. I mean, look at that solder. Yeah, that soldering job. Beautiful. Very heavy duty. Very skookum. Not going anywhere. Okay? So, yeah. By the way, the BMSs are rated to 120 amps continuous. J5 doesn't draw nearly that much continuous, but there again, you got a, you know, safety margin. So, how long is this video? I don't know. God, it's probably pretty long. Anyhow, that's the long and short of this particular portion. I say to you, this is the way that we are doing this, okay? But you're on your own. You're doing this at your own risk, your own peril, okay? I'm not an electronics engineer or an electrical engineer or anything like that. I'm not certified to do any of this or give anybody any sort of professional, You know, so yeah, we're hobbyists, okay? And this is all through a trial and error. So, yep, that's going to be the end of this video. I'm going to put this out there. I know there's going to be a gazillion questions, and let me just say, no, the design's not out there yet. We're still, you know, this is kind of the final assembly. I still have to hook all this up, do all the BMS parameters if they need to be changed. I have to charge it, cycle it, see how it's going to perform, see if there's any issues with battery swelling, which I hope not. At the low C rates we're doing, we shouldn't really have any swelling issues. We are going to recommend that we limit the amount of charging current to about 15 amps. We don't want these cells to swell. We've seen that you know, that they're already a very tight fit, and if they swell a little bit, that could be problematic as far as the structure. This is meant to, you know, you'll notice this cutout, that is for the top roller, the 10-inch roller, okay? That's what that's there for. It all clears. We've got good clearances there. So yeah, we think we've dotted all the I's, crossed all the T's, and when will, you know, a CAD update be out there? I don't know. You know, there's many more items like this that we're currently, you know, tweaking or designing. Yeah, again, please donate. If money is one less thing, you know, funding is one less thing we have to worry about, that benefits you. It makes things go faster. No money, no progress. It just, hey man, it's the way of the world. You know, we're hobbyists. We're doing this. It, you know, we're throwing the money on the fire as quick as we can. Unfortunately, you know, yeah, it's you know, funding dictates the speed of the project. So there you go. This has been Terry Andrews Jr., the J5 Guru, saying I hope you found this video informative, and you're looking forward to some more progress on the Johnny 5 build in design. So, all right, that's it. Talk to you later. Bye for now. And the monkey pushes the button.